Ron's question was, we should round because, what the hell did he say? It was a question based off that. It's been a year, so I've forgotten. But it was such a neat discussion we had about why you have to leave that 0.5 on there.
It makes sense if you're using the exact numbers that you need.
Absolutely.
Exact in the middle, and it also makes sense why you would have just called out group 1 or group 2.
Exactly, because it's basically qualitative data then. But you don't want it qualitative. These are ages. These are continuous data. All right, here's the top. I'm going to put the tops in list 2 if it's okay with you guys. 744, 1910, 1, 0, and 0. And I got 1, 18, 28, 14, 9, 2, 3. Cool. So let's take a look at them, shall we? Let's take a look. Now, one thing the TI sucks at is graphing 2 histograms at once. It's terrible. I'm going to show you why. Okay, that's fine. Now, first of all, let's just turn plot 1 on. This will be the top finishers. See how that's my histogram that from leftover from last time. And this is great, except it's not. Because I have to change this frequency list. Can you take a guess what this needs to be? L1 is actually what the data is. The data is the ages. What does the frequency list have to be now? L2 or L3, depending on which one you want to look at. I'm going to go with L2 for the top finishers. So I need to change that to L2. Now L1 is the data. That's where the data is. And the data that we're interested in is what? Exactly. How old these people are. That's where the data is. That's going to be L1 still. But you have to have the frequency in L2 because that's how many of them were that old, if that makes sense. If you leave a frequency at 1, it's going to assume you only have 6 people in the race. 1 19-and-a-half-year-old, 1 29-and-a-half-year-old, 1 39-and-a-half-year-old, 1 49-and-a-half, and so forth and so on. You've got to tell L2 to say that, oh God, yeah, there are 7 of these and 44 of those and blah, blah, and blah, blah, and blah, blah. Is that fair? You can still go zoom 9. Whoops. Zoom 9. And there it is.
Wow.
That's our top finishers. That's more bell-shaped than I was expecting. I was expecting Aaron's skew, but that's fairly bell-shaped. Let's also, while we're at it, look at the bottom finishers. Now here's why, let me just show you real quick. I'm going to turn plot 2 on to look at the bottom finishers, okay? Riley, go ahead, go ahead. Thank you, sister. That's why we have to finagle a little bit. Watch this. I'm going to turn plot 2 on as well. But I'm going to set it up for the bottom finishers. Now if I do this, this is a bit of a trick question. That shouldn't be L2. What should the X list be if we're looking at the bottom finishers?
L1.
Still L1! The data is still ages, right? The data is still ages. What should the frequency be? L3, because that's how many were in each of those groups. I have subdivided up the top and bottom finishers in the same age groups. But there are different numbers of them in each of those age groups. That's what the frequency is telling me here. So I'm going to change that guy to L3. Fair enough? Now here's what Riley just astutely pointed out. When they lay on top of each other, they're the same color, you can't tell which one is which. This sucks. I can't stand this about the TI. They've never fixed this bug, even though I keep emailing say sorry and he keeps ignoring me. That's okay. I'm probably spam blocked by this point. Excel does this beautifully. It gives you 2 different colors side by side. You can also make them vertically side by side. Lily?
Their online version does it.
It does?
Yeah.
That's okay. I appreciate that. But we have a fix. We have a fix. Here's the fix. Go back into plot 2. Go back into plot 2. Even though the histogram does that, if you choose this guy right here instead, this is called a frequency polygon, which is histogram-y. But just not a, it's remember the first day or second day of class I taught you a bunch of histogram-y things, dot plots, stem and leaves. This is one I held off on because it didn't make sense to talk about then. So if you go down and grab that one, it asks where your X and Y list should be. Now Y list is another fancy way of talking about frequency. So we're going to go ahead and change that to L3. Okay, we're gonna finagle around. We're gonna finagle it a little bit here. And the mark it probably highlights this automatically, and that's totally fine. Go ahead and use that. That's got no problem with that. Okay? Now just press graph. And what you'll get is, you'll get ish a histogram kind of shape on top of the other histogram. It's not perfect. It's not perfect. But what this histogram would look like is something like this. You'd be getting something like these boxes here. It's just a way of cheating on the TI to get the histogram. Imagine it as a curve looking like that. Once again, more of a bell curve than I was expecting. So do we feel okay about finding the average and standard deviation of this data? I do. I'm okay with it because it's more bell curve than I thought it was going to be. Which data has higher variation? Think about that. Let's come back to that question. Which data has a lower average? Let's start with the average. Let's start with the average. Which of the two data sets has, on average, a lower average? Based off just these two pictures.
In age?
This one or this one?
Yeah.
Okay, let's calculate them. Let's calculate them using one of our stats. You ready? Let's synopsize our data. Let's go up here. So we got the PDX Marathon data. PDX Marathon. What I was really looking for in this data was I was trying to see if there's any kind of a difference in the ages, because I keep being told by people distance runners get better as they get older. I keep hearing, everybody heard that before? Distance runners get better as they get older? As I get older, I just get more aches and pains. I give up running. Well, except for Total Fit, I never run Total Fit. I can't do these marathons anymore. It's too much jarring on my body. So I said, okay, maybe there's some truth to that. So I thought maybe if I look at the averages of the top and the bottom, there'd be older fogies up in the top, and the young bucks would be in the bottom. I was just trying to see if that would hold up statistically. I don't know if it would or not, I just wanted to see. So, and Faith's going, not so much. That's okay, I'll come back to that. So what I want to do is I want to do an X bar for both of those. Let's go. I know, I'm sorry, Cora, I'm sorry, I'm almost done. It's painful, I know, it's very painful. So, let's get the X bar for the top. So what you're going to do, go to your stat menu. Remember how you got X bar before? You went to one bar stats? Now you might be tempted to press enter right now. You go ahead and do it. What the hell? Go ahead and do it. Now the problem with this is, can anybody see the problem with this?
It doesn't show the top or bottom.
Wait, say that again, Riley.
It's not for one or the other.
See, the problem with this is, it thinks there are 7 people in the race. That's because if you just tell it one bar stats and nothing else, it's going to average L1 and only L1. So remember what I said before about it now thinks there's one 19-year-old, one 29-year-old, one 39-year-old? That's what it just did. Which means all these numbers are off. The average age is not 49. That's too high. So what you have to do is tell the TI how to deal with when you have frequencies in one. It's pretty simple. It's pretty straightforward. You ready? Here's all it is. Go to Calc. Go to one bar stats. But just don't press enter right now. Tell it L1, so second one, comma, which is right above the 7 button. And guess what comes second? L2. This,
An L3, L2.
that's okay. We're doing one at a time here, Riley. We're going to do the top first, then the bottom. So right now, we're only calculating the top. So right now, the average age of a top finisher is about 34 years. Which syncs up with that graph pretty well. If you look back at that graph, that's pretty much where the high point of that graph was. So we get an average of about 34 years. What's the plus or minus on that bad boy? Looks like about 8.5 years. We'll call it 9. We're around 9. About 9 years. What's cool about that is we can apply that 9 plus or minus to the average if we wanted to. I won't do it because that can get the conversation drawn out pretty far. Lily, go.
Why would you use 2 bar stats?
2 bar stats assumes there's a correlation between L1 and L2. I don't assume that. I don't want to assume. You're asking the 244 question. It's a great damn question, actually. I don't want to assume there's any kind of a connection between the top and bottom finishers without any reason to believe there is.
It comes up with the same number.
It does, but it also gives you other correlation numbers that people might inadvertently grab. The problem with getting all these numbers thrown at you is it's all there in front of you. Like, ooh, And then it's like, which ones do I grab? That's why I'm trying to teach you, ignore them, ignore that, and only focus on those two. 2-bar gives you even more that you have to ignore. Is that fair?
Yes.
It's not a very good answer, but it's kind of like, I'm trying to build only the toolbox you need right now, not anymore. Because otherwise, it's just too many shiny objects to play with. Fair? Maybe? Ish. Kind of getting there. Let's check the bottom finishers. Let's check the bottom finishers, yes?
Yes.
All we gotta do, now watch this trick. You may have forgotten this trick from back in the day. Second enter. If you type second enter, it grabs the last thing you entered, but then you can go back in and edit it. So all you gotta do then is back up 1 and replace the L2 with an L3. We wanna leave the L1 in the front, right? Because that's still the data is the ages. But the L3 is the frequencies, yes? Oh, I think so. Maybe. Kinda. Ish. Enter. What's the average age of a bottom finisher? 43 and a half! We'll call that 44 years if you want to round off. I'm just rounding off to the nearest whole year. It doesn't matter to me what you got. With a plus or minus of 13. So remember when I asked which data was more variable? Which data appears to be more variable? The bottom. Now, look at the graph again. Can you see why it's more variable? If you were to trace a curve on that's the bottom curve I just did in black.
Skewed right.
And then we did a curve on the blue. Which curve is wider? Yes! Alicia, you got it. The bottom one is wider. The top one is tighter. Tighter means less variable, which means the standard deviation is going to be less. Ha! Which one has the larger average? We can tell the bottom one is. Can you see how that plays in with the graph? It's to the right of this one. The average of the blue one is left of the average on the right. Mathematically and numerically, to the right means larger. So the reason I looked at this data originally was I was trying to see if the old fogies were kicking ass in the marathon. This does not give me that, this does not show that to me, right? It shows the old fogies finishing in the bottom, but that's an oversimplification. I didn't look at the entire data set, I looked only at the top and the bottom. Maybe something else is happening in the respectable middle, people that are finishing marathons in 3.5 hours and 4 hours. Maybe something cool is happening there, I don't know. We can look more. But that wasn't the point of today. The point of today was dealing with all kinds of different data sets, which I think we now dealt with, yes. We good? We feeling good? Yeah. Any last comments, concerns, points to bring up? I realize my volume has gotten louder the entire class. I apologize for that. So I'm yelling at the end. Oh, goodness. Okay, so let's, in-class quizzes right here as you guys take off. We'll get them back to you guys on Wednesday. We'll have a progress report this afternoon.
Wednesday.
Cool? Wednesday. Wednesday. Yes, Wednesday.
Did you show me how you got it?
Of course. Let me kill this. Get this